45 degrees of Celsius. That is a very large amount of energy in order to extract aluminium from this compound. Therefore, the melting point of this compound should be reduced, at least to make it economical, in order to make the extraction easier. So another compound should be added, should be mixed with aluminium oxide in order to reduce the melting point from 2045 degrees of Celsius at least to about 900 degrees of Celsius. And this compound is the chlorite. So that is reason number one. Reason number two is that this aluminium oxide is having the covalent tendency. That covalent tendency makes this compound to have low electric conductivity. So in order to increase the electric conductivity of this compound, the chlorite will save for that particular part. So the chlorite is having two rules. Rule number one, to reduce the melting point of aluminium oxide from 2045 degrees of Celsius to about 900 degrees of Celsius. That is rule number one. Rule number two of the chlorite is to increase the electrical conductivity of the solution. So those are the things that you have to understand using this compound, which is aluminium oxide. Therefore, the compound which is chlorite is written as, the formula of it is sodium hexafluoroaluminate 3. That's the compound. In order to save two functions. That is rule number one. And rule number two, I can ask you the question, why aluminium oxide has the covalent tendency? It's because of the high polarizing power of aluminium cation, the aluminium. This cation is highly polarized because of the high cationic charge. That's why its compound is having the covalent tendency. So after the addition of this compound, which is sodium hexafluoroaluminate 3, by saving those two compounds, now aluminium oxide can be used now for electrolysis. Now here we go to electrolysis process. Electrolysis process, the electric current decomposes this compound, aluminium oxide. This will be as follows. So this compound will be decomposed by electric current to produce these ions. Now, if that is the case, what will be the electrode reactions? We start at anode. At anode, this oxide ion will migrate to anode. And when it migrates here, it will surrender these electrons and become discharged. And when it becomes discharged, it forms oxygen gas. Therefore, it will be like this way. As you can see, so oxygen gas is produced at anode. And at the cathode, here we are going to have this aluminum ion will be discharged at the cathode. The equation will be as follows. So you can see, so this aluminum ion will be discharged and form aluminum metal. Therefore, aluminum metal will be deposited at the cathode. So as time goes on, the cathode will be larger in size because of the deposition of aluminum metal on it. But remember, the electrodes that are used, the nature of the electrodes that are used are carbon electrodes. Specifically, the graphite. Now, because the electrode which are used are carbon electrodes or graphites. Now, my dear students, here oxygen gas is formed at anode. This oxygen gas may oxidize the carbon electrode into carbon dioxide. So there is a need for these electrodes to be changed constantly in order for the process to continue because of the oxidation process that is taking place at anode, because oxygen gas which is produced here can cause the oxidation of that particular compound. So that is the extraction of aluminium. So the aluminium which is obtained here will be pure and it will be deposited at the cathode. So it is very simple for you to understand these very simple steps, because you can be asked this question: describe the process of extraction of aluminum metal. You need to understand each step. You need to analyze the steps and the balanced chemical equation. And it is important also to state the state symbols for all the chemicals that are involved in that particular reaction. So, my dear students, this is how we extract this metal, and I hope that you have obtained the knowledge on how to extract this metal. Therefore, I hope that you are following this program, and let's be back after a short break.
You are watching Darasa Online.
Now, my dear students, so we have seen the extraction of aluminium from the ore, which is the bauxite, and it is very, very important for you to understand these steps. And I've told you that you have to follow each step with the chemical questions and to balance the chemical equation. It is important. You know, some of the students, when they're answering these questions, they just give explanation without chemical questions. So this becomes a problem. You might find that if the question, for example, have 80 marks, you may get 3 or 4. Then you miss the rest of the marks because you have not written the balanced chemical question. So it is important for you to follow. Now, from here, I want to take you to some of the examples, the competence-based questions that you can meet with from this particular presentation, because it is important also to know how the questions are coming from this particular part. And from there, you can get the knowledge of answering different questions. It is important. So let me take you to the questions that are coming for this particular part. Now, let's go to question number 1 on this particular part. Now, question number 1, my dear student, says, question number 1A, explain briefly the extraction of copper from its ore using the following headings. Number 1, froth flotation. Number 2, roasting of an ore. Number 3, removal of iron 2 oxide as an impurity. And number 4, auto-reduction. That is part A. And part B, describe the electrolytic purification of copper under the following headings. Roman 1, we have the chemical nature of the electrodes. Roman 2, we have the chemical nature of the electrolyte. And number 3, we have the redox reactions involved. So this is the one of the questions that you might meet with when doing different examinations. Now, let's solve these problems together on the board.
You are watching Darasa Online.
Now, let's solve that problem, my dear students. It is very simple to solve this problem. Number 1, the heading says froth flotation. When you go to this step, it is important first to know the ore that we can extract copper in large scale. It is important. The ore for copper is copper pyrites. This is the ore that we can use to extract copper in large scale. Now, this ore can be contaminated with other impurities. So to remove the impurities from this ore, now we use froth flotations. I'm just guiding you on how to solve this problem because I'm sure that you have studied this in the class. Now, froth flotation, this is the method which is used to remove the earth impurities from the sulfide ores. Now, what is happening to these problems? I have described this in a very good way in the previous lesson. That when the impurities which are found in the sulfide ores are water weighted, that means they are hydrophilic. And the ore itself is hydrophobic. So if that is the case, the ore is taken and crushed into powder, mixed with water, followed by the addition of pine oil. The emulsion will be agitated by compressing air to the mixture. So that one will cause the oil and the froth to come and float on the surface along with the ore. So the froth will contain the ore and will be taken for further process. So that is all about froth flotation. So after having this process, we go to the next step. The next step, my dear students, is talking about roasting of an ore. Remember, I'm just guiding you on how to solve this problem. This step, roasting of an ore, can be done in the following ways. Number 1, what you do, here is just the heating of the ore in a limited supply of air. So the following chemical equations can help you in order to understand this particular step. This ore is taken. When it is heated, these are the products that will be formed. We have copper 1 sulfide, we have iron 2 sulfide, and we have sulfur dioxide. And also, here we are going to get copper 1 sulfide, These are the products that you're going to obtain. So it is very simple to do this process. So this is roasting. Now here, after we have this roasted product, the further process of heating this roasted product in a limited supply of air will continue. The aim of continuing with this roasting process by heating to a limited supply of air, number one, is to convert this iron 2 sulfide into iron 2 oxide. And the sum of this copper 1 sulfide, either this one or this one, will also be oxidized into copper 1 oxide as follows. Now the chemical equation are as follows. So that is number one. So here we have iron 2 oxide. Also, this copper 1 sulfide will be oxidized or converted into copper 1 oxide. So my dear student, you can see. So here we have copper 1 oxide, we have iron 2 oxide, and we have one of the unreacted copper 1 sulfide. These will go to gas. These are gases. Now from there what happens? Now we remain with the following. The mixture now will consist of the following. We are going to have copper 1 sulfide, which was unreacted. We are going to have iron 2 oxide, and we are going to have copper 1 oxide. These are the three things that we're going to have in the mixture. Now we want to remove this one, this impurity. Should be taken away. What are we going to do? We add this silicon dioxide to this mixture. And the silicon dioxide will react with this iron 2 oxide to form iron 2 silicate, which will be removed as a slag. So here, my dear students, will be as follows. The reaction that will take place will be as follows. So this will be removed as a slag. So from there, the iron 2 oxide and copper 1 sulfide and the copper 1 oxide will not react. So at the end, you're going to remain with these two. Now, what is the next step? So here we have finished with the roasting, the frothy flotation. We have finished with roasting of the ore and the removal of as iron 2 as an impurity. This is the step here. So the last step is auto-reduction or self-reduction. So these two remaining compounds, copper 1 sulfide and the copper 1 oxide, will react together to form copper, and that is autoreduction. That is the one. So what you can do, you can just put there 2 and you put here 6 to make this and this one to make 6 copper, as you can see, and sulfur 1, 2 oxygen, 2 oxygen. So this is the gas and this is the solid. So this is the metal that we were looking for, copper. This copper, which is obtained by autoreduction, is called blister copper. So after we have this copper, the other process can continue because this is not yet pure. It still consists of some impurities. Now to remove the impurities, we go to the second equation, or the second part of the question, which says as follows. Question number 1b, it says as follows. Describe the electrolytic purification of copper under the following headings. Number 1, chemical nature of the electrodes. Number 2, the chemical nature of the electrolytes. And number 3, the redox reactions involved. So this is the second part of the equation, which is important in order to complete the extraction of the copper metal from its ore. So let's go back to the body to see how those processes, how those 3 parts of the equation can be done. Now B. Number 1, we have the chemical nature of the electrodes. The electrodes that are used in this particular process of purification, first of all, the purification of copper metal is done by electrolysis. That is important to consider first before we proceed to the rest of the question. Electrolysis. Now coming to part 1, the nature of the electrodes that are used in this process of purifications are copper electrodes. Copper electrodes. The impure copper will be made the anode, and the pure copper will be made the cathode. Will be made the cathode. So from here, this is to explain the electrodes, the nature of the electrodes. But you can ask yourself a question, why copper electrodes are used and not carbon electrodes? If you use carbon electrodes, there you are going to other product. You're going to get hydrogen gas and oxygen gas at the electrodes. So you're not going to get the copper as you want. So the nature of the electrode should be used a copper electrode for you to get specifically the copper metal that you want. So this is the first part of the question. The second part of the question, it says the chemical nature of the electrolytes. Chemical nature of the electrolytes. Now, the chemical nature of the electrolyte, the electrolyte that is used here is the copper 2 sulfate, which is acidified with sulfuric acid. That is the electrolyte that you're going to use, copper 2 sulfate. Now, from this particular part, we go to the last part of the question, the redox reaction involved. When you talk about redox reaction, what do we understand, my dear students? Redox reactions, here we are referring to reduction and oxidation. So here we are going to have the oxidation, half reactions, and you're going to have reduction, half reactions. So starting with the oxidation, half reaction, this is taking place at the anode. So if you remember here, the impure copper was made the anode. That means this impure copper will dissolve into this electrolyte in the solution, producing copper 2 ions, and that is oxidation. Therefore, at anode, we are going to have the following. We dissolve in the solution to give this ion. So this will make the solution blue because the nature of this copper 2 ion is always blue. So you can be asked why the solution is blue. Is due to the formation of this copper 2 ion. So from there, we can say that at anode, there is a formation of this copper 2 ion. Now what happens to the cathode? This is a half oxidation, a half reaction. We can go to the reduction. A half reaction. Reduction takes place at the anode. At the cathode. So what will take place? What will take place here is this copper 2 ion will migrate to the cathode and be deposited there. Therefore, it will be as follows. Therefore, at the cathode, you're going to have the following reaction. Finally, we have the copper metal which is deposited at the cathode. And this copper metal which is deposited here, it is very pure. Now, we can have a little illustration here on the board on that electrolysis process. These are electrodes. This is the battery. This is the copper cathode. and this is the copper anode. This is the solution, which is acidified copper 2 sulfate solution. And this copper anode, because it is impure, that means it will dissolve and the impurities will be dropped down at the bottom this way. So these are impurities. So the copper 2 ion which reformed will migrate and be deposited at this cathode. So as time goes on, this copper anode will disappear because it will dissolve in the solution, forming the ion, and this copper cathode will increase in size, will be bigger in size because of the deposition of the copper on it. So this is the redox reactions that are involved at the electrodes. We have the oxidation half reaction at the anode, and we have the reduction half reaction at the cathode. So this is how the extraction can be from that particular part of the question. So it is very important for you to extract. So it is very simple to balance the chemical reaction. So it is your work also to balance the chemical equations that are involved in the particular reactions involving extraction of copper. So from there we can proceed to the other question that you might meet with in this particular presentation. Now let's go to question number 2. Question number 2 says, why some metals cannot be extracted by thermal reduction method? Give reason. Now, my dear student, this question is very simple. And if you remember the previous lesson, we discussed together the methods of reduction. It is very simple. Some metals cannot be extracted by thermal reduction. If you remember it very well, it won't be a problem. So you can follow the last lesson. We discussed together about these reductions method, which are very simple. That thermal reduction is for metals which are found below, or they are found at the bottom of the reactivity series. That means they are less reactive. So metals which are only found at the bottom of the reactivity series are the ones which are extracted by thermal reduction, by just heating. But those which are found at the top, for example, sodium, potassium, aluminium, they are strong reductant, so they can't be extracted by this method of reduction. They need strong method of reduction, that is electrolysis. So if you remember that one, there is no problem. Now for the case of part B, explain the following facts. Roman 1. Although nitric acid is a strong oxidizing agent, it is transported by using aluminium containers. This is also another very simple question that you can meet with. If you meet with this question, what are you going to do? What are you going to answer? Now, nitric acid renders aluminium passive. How? Because there will be a formation of a thin layer of oxide. That is, this is aluminium oxide. This will prevent further reaction to take place. So in this way, the general reaction won't take place. So that's why the concentrated acid, it can be transported using the aluminium containers, because the thin, strong protective layer which will be formed on the surface of the aluminium container will prevent further reaction to take place. That is the reason that you can use to answer that particular problem. So it is very simple. Now for the second part, common reducing agents have no action on aluminium ore. Why? We have also discussed this one in the previous lesson, that aluminium is one of the reactive metals. So it is extracted by using the strongest method of reduction, which is electrolysis. But the common reducing agent can't do that. When we talk about common reducing agent, we are talking like carbon or carbon monoxide. These ones are not strong enough to react with this one, to reduce aluminium ore. In fact, even aluminium itself can react with those reducing agents. For example, it can react with the carbon to form the carbide, that is aluminium carbide. So the strongest method of reduction is used on this particular part. So that one is also very important, and it is very simple if you remember the previous lesson. So we can see the question number 3 to see also another form of the question that you may meet with from this particular presentation. Question number 3. Question number 3 says, in the electrolytic extraction of aluminium from fused mixture of aluminium oxide and chloride, about 80 kilograms of the chloride are lost when a ton of aluminium is produced. Now, A, what happens to this chloride? B, why is aluminium being reduced instead of sodium in this electrolyte? This question is also very simple, my dear student, to answer, because I have explained the function of the chloride. It is very simple. Here, when we talk about the function of chloride, why are they lost? What happened to the chloride? Chloride, I have told you that they are used to serve two functions. Number one, to reduce the melting point of aluminium oxide from 2045 degrees of Celsius to about 900 degrees of Celsius, which is very economical for the extraction process to take place. So that is rule number one. So it is consumed during that process. But number two, it is used to increase the electrical conductivity of the solution, because aluminium oxide has got the covalent tendency. So in that way, the chloride is consumed during the reaction. That's why they are lost. So that is a very simple one. And also why aluminium is being reduced instead of sodium. In this one, it is also very simple for you to answer that question, because you can compare the reactivity of aluminium and the sodium. So it is very simple to answer these particular problems. Now, my dear student, these are the questions that you may meet with from this presentation of today. So the extraction of metal is very, very important, because it is used to make different materials which are used in your daily life. Even there at home, where you are staying, there are so many tools which are made of metals, so many things, including the roofing materials, the doors, the wire mesh, you see, utensils, different materials can be used, can be made from the metals. So it is a very important part of our life. Now let me take this opportunity to thank you for following this program, and I hope to meet you in the next lesson. Have a good time.
Kipindi cha Darasa Online kimeletwa kwenu na Chuo Kikuu cha Sauti Mbeya. Kipindi cha Darasa Online kimeletwa kwenu na Chuo Kikuu cha Sauti Mbeya.
Hello students. This is Darasa Online. It's my pleasure